This next section is about looking at the sine and cosine function as functions, and one of the things that we can do with a function is we can graph them. We can think about the input. The input for the sine and cosine function are both going to be angles on the unit circle. The output for the sine function will be whatever y-coordinate we're at on the unit circle. And the output for the cosine function is going to be whatever x-coordinate we're at on the unit circle at that angle. So as we change our angle, what happens to the y-coordinate would be sine. As we change our angle, what happens to the x-coordinate would be cosine. Here's a real-world example of a sine function in the real world. The graph shows the rider's height above the platform when riding a Ferris wheel T minutes after entering the Ferris wheel car. So imagine that you are the rider and you get on let's say the red Ferris wheel. The red gondola car. As the Ferris wheel goes around, your height goes up. The height of your body goes up until it reaches the top of the circle, and then the height of your body goes down. And it continues down until it reaches the bottom of the circle. So it's not, the reason the graph is not a circle, sometimes people think, oh, this graph should be a circle, is because it's only measuring the height. It's not measuring the x distance at all. It's just measuring how high off the ground are you as time passes. So the x-coordinate is the time passing, and the y-coordinate is how high you are on the Ferris wheel. Because the Ferris wheel is a circle, you start on this one at the ground level, and then you go all the way up to the top of the circle, and then you go all the way down back to the ground, and then you go all the way back up to the top of the circle again. So if we think about that, which graph shows a Ferris wheel with twice the radius of the original Ferris wheel? This is our original graph, and if we look at these graphs, it looks like graph A has a radius that's the same as the original because this distance is still 20, right? So our head went 20 feet off the ground. The difference with A and the original is that I have to climb a ladder in order to get up to my gondola car. I have to climb up 20 feet in order to get on the ride. So that's A. A is not one that has twice the radius. A is one you have to climb up to. B, I get on the gondola car at 0, and then my height goes all the way up to 40 and then back down to 0. So B looks like a good answer to this question. That has twice the radius. Just going to quickly look at C. What's going on with C is we're starting at ground level. We're going to 20 feet off the ground. We're going back to ground level. It's just taking us longer to get there. So C is a graph of the same Ferris wheel as the original, but slowed down. It takes twice as long to complete a lap. All right, so these graphs are, I'm just going to back up a little bit. B is also I want you to notice, a vertical stretch. We stretched our graph vertically to get B. This is a graph of a Ferris wheel. We want to find the one that's going twice as fast as the original. So it looks like for the original, we start at t equals 0, we finish a lap, we get back to where we started at t equals 2. So it takes 2 minutes to complete a lap. If I look at Ferris wheel A, that one, we're starting actually 10 feet off the ground, so we have to climb a ladder to get to that one as well. But it takes us 1 minute to get back to that level. So Ferris wheel A looks like it is going twice as fast. If I look at Ferris wheel B is actually going slowly. It's going twice as slowly. It takes 4 minutes to complete a cycle. And Ferris wheel C, it is another one where you have to climb a ladder to get up to the top, to the car that you start on, and then it looks like it's still taking 2 minutes. It's just starting at a different spot. So Ferris wheel C and Ferris wheel A are and the original, are very similar, just starting at a different spot. It's important that you understand that sine and cosine are periodic functions. As you spin around the unit circle, you're going to start repeating values. So just like on a clock, if it's 3 o'clock and I let the minute hand continue around, it's going to hit 3 again. So sorry if the hour hand spin around. It's going to hit 3 o'clock again in 12 hours, and it's going to keep repeating that cycle. Sine and cosine do that same thing. Some definitions before we start graphing, just so you know what these words mean. The midline is going to be a horizontal line of symmetry. It's the line that cuts the graph in half. So for this particular example, I just put an example here so it's easier to talk about. Y equals 1 is going to cut our graph in half. We have equal amount above and below the x-axis. The amplitude is going to be the vertical distance from the maximum to the midline. Oops. Or from the minimum to the midline. So for this particular graph, the amplitude is 3 because the maximum is at 4 and the midline is at 1. So that's a distance of 3. Or the minimum is at -2 and the maximum is and the midline is at 1. So that's a distance of 3. The period is how long it takes to complete a cycle. So for this graph, the cycle starts at the midline, goes up to the maximum, back to the midline, down to the minimum, and then back to the midline. It takes 2 pi to complete a cycle on this graph. The frequency is so the amplitude is a vertical stretch. The period is how long it takes to a cycle. Frequency is very related to period. So these two are very much related. Frequency is how many cycles you can complete, and 2 pi is the standard. That's all the way around the unit circle. So frequency is how many cycles you complete in 2 pi. So for this graph, the period is 2 pi and the frequency is 1 because it completes 1 cycle in 2 pi. If you make your Ferris wheel go faster, your period is going to get shorter. Your period will be smaller. But if you increase the speed of your Ferris wheel, the frequency would get larger. The frequency would be how many cycles you can complete in 2 pi revolutions. All right, so here's a graph of sine. Remember, sine is just measuring the height on the unit circle. And so if I look at this graph, and I know this is graphed for you, I just want to kind of follow what's going on. So at x equals 0, and remember, this is not the x coordinate on the unit circle, this is the angle. So when the angle is 0, the y coordinate is also 0. So think about your unit circle. The y coordinate is 0 when you're at this spot on the unit circle. Okay. Pi over 6 means we're up to here on the unit circle. So that's my input. My input is the angle. And then my output is going to be what my y coordinate is at that point. So my y coordinate is 1/2. And then I continue up the unit circle. My y coordinate gets bigger. So it's going to be √2/2. And then it gets bigger again. It's going to be √3/2. And then it gets to the top of the unit circle. So my y coordinate is 1 when my angle is pi over 2. So this is a maximum value right here because we've reached the top of the unit circle. And then we continue back down the unit circle. So the maximum for this graph of sine is 1. And the minimum is going to be when we're at the bottom of the unit circle. The minimum is going to be -1. We can't get any lower than -1 because our unit circle is stuck there. The midline, when the sine function is graphed without any shifts, The midline is going to be at y equals 0, or the x-axis. If I do a vertical shift, that would affect the midline. Remember I talked about climbing up the ladder to get to the gondola car? That would be a vertical shift. The amplitude is, for this graph that hasn't been stretched at all, the amplitude is going to be 1 because that's how far it is from the maximum and the minimum back to the midline. The period is how long it takes to complete a cycle, so that's going to be 2 pi is going to be how long on the x-axis it takes to complete a cycle. Frequency is how long it takes, how many cycles you can complete in 2 pi, so that would be 1. The domain is all real numbers because we can keep spinning around that unit circle infinitely many times. You could describe that as all real, or if you like doing negative infinity to infinity, you could do that as well. The range is going to be not all real numbers. If you put your pencil on the lowest point has a y-coordinate of -1. There's actually more than one place where it hits that lowest point, but it never goes any lower than -1. And there is actually a value at -1, so we're going to put a bracket around it because it exists. And then we're going to put our pencil on the tallest point. The tallest point is at +1. So our range goes from -1 to 1, and it repeats those values over and over again, but it never goes any higher or lower than those values. The y-intercept for the sine graph is going to be when your angle is 0. So the y-intercept for the sine graph is 0. It's right here on the graph. It is when your angle is 0. The x-intercepts are going to be whenever your y-coordinate on the unit circle is 0. That's confusing, but it's where we go. So it's going to be every time your value is 0. One of the times the y-coordinate is 0 is when we're over here at 0. The next time the y-coordinate is 0 is when we're over here at pi. And then it repeats every pi, the y-coordinate is 0. You can see that here. Every pi, the y-coordinate is 0. So the x-intercepts are going to be 0, pi, 2 pi, 3 pi, etc. That is the graph of the sine function. This is a sine function that hasn't been transformed at all. No vertical stretches, no shifts. This is the parent function of the sine function. I'm going to have you just look at this animation for a minute. These are the unit circles showing you as the angle changes around the unit circle, the sine function is measuring the x-coordinate and the y-coordinate, the height, and the cosine function is measuring the x-coordinate. They look the same, don't they? The only difference is kind of that horizontal shift. When we're at 0 on the unit circle, the x-coordinate is 1. So the cosine function has an x-intercept of 1, while the sine function has an x-intercept of 0, a y-intercept, sorry. All right. So I just wanted you to see how it's related to the unit circle. As the angle changes, the x-coordinates and the y-coordinates are both changing, and those are creating our two functions. So here's a graph of cosine. I'm going to quickly go through. The maximum is still 1. The minimum is still -1 because those are the highest and the lowest values. The midline is going to be y equals 0. The amplitude is going to be 1 because that's the height of that graph. The period is 2 pi. The frequency is 1 because it takes 1 to complete 2 pi. The domain is still just like with the sine function. It's still going to be all real numbers. And the range is still going to be the same. It's going to be -1 to 1. All of those are exactly like the sine function. The only difference is the y-intercept and the x-intercept. So the y-intercept for cosine is right here. The y-intercept is 1, and that's because when the angle is 0, the x-coordinate is 1 on the unit circle. The x-intercepts, the times that the x-coordinate are equal to 0, are going to be at the pi over 2's. So pi over 2, 3 pi over 2, 5 pi